The next homologous series is the homologous series of the esters. The homologous series of the esters. So esters, they are also called alkanoids. Alkanoids. Or you can call them alkyl alkanoids, right? But you call them the alkanoids. So you can call them the alkyl alkanoids, right? So the general formula for the esters is RCOO R prime. RCOO R prime. RCOO R prime. So let me try to write down the structure so you can get it, right? So you have something like R bonding to carbon, carbon having a carbonyl, right? You can see this carbonyl, then oxygen bonding to R prime, right? So this is how it is, or let me say, this is how an ester looks like. This is how an ester looks like, right? So I believe you know that this R and R prime, they are both either alkyl groups or aryl groups. But for your JAMB exam, it will always be alkyl groups, right? So now, let us talk about the members of the esters or the alkanoids and how they are formed, right? So now, esters are formed through esterification reactions, right? Esters are formed through esterification reaction, which was something I was explaining under the reactions of the carboxylic acids, right? So I said that esters are formed through esterification reaction. And what is esterification reaction? Esterification reaction is the reaction between a carboxylic acid, let me just write Ca, reaction between a carboxylic acid plus an alkanol or an alcohol, a carboxylic acid plus an alkanol, let me write it, alkanol, then it's always a reversible reaction, an alkanol, to form an ester plus water only. This is esterification reaction. So the forward reaction, we call it esterification reaction, while the backward reaction, we call it hydrolysis, right? Hydrolysis, right? So normally you should know that an ester can be hydrolyzed to form an alkanol and a carboxylic acid, right? So the reverse process of esterification reaction is hydrolysis, right? So now let me tell you guys how these are formed. So now you can see in this formula, you can just see RCOO R prime. You can ask me, what is this R? I say it's an alkyl group. Yes. What is this R prime? It is also an alkyl group. But where are the alkyl groups gotten from? This particular R that you see here is the alkyl group of the carboxylic acid, right? The alkyl group of the carboxylic acid, right? Why this R prime is the alkyl group of the alkanol, the alkyl group of the alkanol or of the alcohol, right? Okay, let me try to write a reaction for you guys. I'm going to find a very simple reaction to use to explain for you guys. Okay, let me use C2H5COOH. What is the name of this? This is propanoic acid. That's correct. Reacting with what should I use? C3H7. No, let me not use C3H7. That's going to be easy for you to know. Let me just use C2H5OH. This is ethanol, right? To give, if propanoic acid reacts with ethanol, what will it give us, right? So it's going to, this is acid and alkanol. Normally we should know that it will give us what? An ester and water. But now, how do we get the ester? We are going to get the ester from this particular formula, right? So you should know that this R is from what? The alkanoic acid. So what is the R in the alkanoic acid? C2H5. So you're going to write your normal C2H5, right? You can see how I'm deriving the ester. Then you write your COO from the formula now. RCOO. You write your COO. You can see that this COO is actually coming from what? All of this C2H5CO is coming from the carboxylic acid, right? So then our R prime is gotten from our alkanol, right? Our alcohol. So you write it C2H5. Now you can see that then plus water, right? Plus water. Now you can see that this reacted from this our C2H5COO minus reacted from this carboxylic acid remaining hydrogen ion, right? Remaining hydrogen and just hydrogen left. And here, C2H5 reacted with this remaining OH, that's hydroxyl ion, right? If hydroxyl ion and hydrogen ion react together, that will give us our water, and that was how water was formed from this esterification reaction. I believe this is very simple to understand. Now, this is a very simple thing. So this is just basically a esterification reaction. The reverse is hydrolysis, right? So now, what is the name of this ester? You see, we are already going into IUPAC small. We are already going into IUPAC. I want to treat the IUPAC at once because IUPAC of esters is very, very simple. The IUPAC nomenclature of esters is very, very simple. So now, what is the IUPAC name of this compound? To name esters, we always name esters from behind. Let me write it. C2H5, COO, then C2H5, right? We usually name esters from behind, right? We name the R prime first. This is the R prime. You know, this is RCOO, R prime, right? We name the R prime first, which is C2H5. We name the R prime first before we go back to the R. We are not naming from the front, right? So what is this R prime? C2H5 is what? Ethyl. So you're going to write ethyl. Then you go back to the R and the COO group to complete the naming. Don't forget that I told you that esters are also called alkanoids or alkyl alkanoids. So now you can see you go back to this RCOO compound, right? Then you count the number of carbons to know the prefix you are going to use for the noate. You need to know the prefix you need to use, like if it is 3, 4, 5, 6. That's the number of carbon that determines starch, right? So here, how many carbons do we have? We have 2 carbons here, and this COO2 also has 1 carbon. So that is what? 1, 2, 3. So that's 3. What is the prefix for 3? That's prop. So you are going to be having ethyl propanoate. Ethyl propanoate. You can see this is ethyl propanoate. This is very, very simple. Ethyl propanoate. You are going to name the R prime first, then you go back to the R. So ethyl propanoate. Let me give you guys another example. It's going to be very simple. Okay, let me just use this one. HCOO C3H7. This is also an ester, right? This is also an ester. It is very simple. Very, very simple. The first you name your R prime first, right? C3H7 is what? Propyl. So you write propyl, right? Propyl. Then you go back to your normal R. You count number of carbons for the R and number of carbons with the COO. You count it together. And if you check here, you can see this is only hydrogen. It does not have any carbon. So you just count only the carbon from the C group. And that is 1 carbon. So, and that, what is the prefix for 1 carbon? That is meth. Like meth, as in methane. So it's going to be propyl methanoate. Propyl methanoate. So I believe you all know that the ending of esters is always noate. Like the suffix is always noate. Don't forget that. Noate. Right? So let me give you guys another example. You see that this is very simple. C3H7 COO. Then let me just put CH3. Right? How do we name this? We name the R prime first, which is this, and that's a CH3, right? So CH3 is what's methyl. Then you count the number of carbons at the R prime and COO side. We have 3 carbons here and we have 1 here. 3 plus 1 is what? 4. So what is the prefix for 4? That's buth. So it's going to be methyl butanoate. You can see that is very, very simple. Methyl butanoate. So now let me give you guys an example. Let me give you guys a classwork that you should do and write the answer in the comment. Which one? Okay, C4H9 COO, then C3H7. So what is the IUPAC name of this particular compound? Right? Write it in the comments and I'll be in the comments letting the correct answers. So that is it. So